Hello students, welcome to our series. So that was the question. You would have got the question from limit, and see again, whenever we have to solve a question of limit, the first step is to decide which indeterminate form is it, if it at all it's an indeterminate form. So which form is it? So of course that you can easily check. As x goes to like 2, it's 4 and 3 raised power x minus 1, which is minus 3. So 1 raised to the power. Now we have to decide for ln x minus ln 2 over x minus 2 whole square as limit x tends to 2. To which value is it approaching? Because see, without deciding this one, you just can't claim it to be 1 raised power infinity. Be very sure that whenever you are trying to solve a question of limit, you have to be very sure about the indeterminate form in which it gets converted. Okay, so now let's try this one. See, so I can write this as limit as x approaches to ln of x by 2 over x minus 2 whole square. Now my suggestion is simple. Let x minus 2 be t, so that means I can write it as limit as t approaches 0, and then this will be, and then see, as x minus 2 is t, so I can replace x by t plus 2, so t plus 2 over 2 by t square. So what is it? So limit as t approaches 0, this is nothing but ln 1 plus t by 2. Now we got the form, so into 2 into t here. Now ln 1 plus z upon z. So ln 1 plus z upon z is nothing but 1 as z approaches 0. So here z is t by 2 and t approaches 0, hence z approaches 0. So that's 0, but you are left with 1t in the denominator. So that's 1. Of course, I'm sorry, that's 1. Okay, but you are left with 1t in the denominator, and as t approaches 0, so this entire term approaches infinity. So hence this is nothing but 1 raised to the power infinity form. Now whenever I have to solve 1 raised to power infinity form, what we do is we always take help of this form of the limit, the standard result, and I always say to my students that for every 1 raised to power infinity form, this is one result which I always use. So, I mean, there's nothing for me beyond this result for 1 raised to power infinity form if fx is a continuous function. Okay, so that's it. So I'll be using the same here. So therefore, limit is just a minute. Yeah, therefore, limit is limit as x approaches 2. So see, do you have 1 plus f of x here? No. So you don't have to apply brain here. That's what I suggest. You have to just get it in that form. So just add 1 and subtract 1, bachcho. Nothing else is required, isn't that? And in denominator we already know it's x by 2 upon x minus 2 whole square. Sorry, in power, not in denominator, in power. Okay. But now, see, so that is our f of x. So I can write it as limit as x approaches to 1 plus fx, and of course this has to be approaching, this has to approach 0, so this is approaching 0. You can check it because that was approaching 1. Okay, we all know it. Into f of x. So I multiplied and divided power by f of x into whatever you have. So you have ln x by 2 over x minus 2 whole square here. Okay, now this is as x approaches a, so this entire thing approaches e. So I will, since e exponential function is a continuous function, so limit can go inside e. So you have limit e raised to the power limit as x approaches 2. So you have 2 raised to power x, which is f of x, minus 3 raised to the power x minus 1 minus 1 into ln of x by 2 over x minus 2 here, and I brought 1x minus 2 here. Why so? Because see, we have already checked that in this case 1x minus 2 can be adjusted with ln term. So we have one extra x minus 2, so that's why I brought it here. Now I will suggest the same thing which we did to check the indeterminate form. Let x minus 2 be replaced by t. So therefore limit is e raised to the power limit t approaches 0. So it's 2 raised to the power t plus 2 minus 3 raised to the power t plus 1 minus 1 upon t into ln 1 plus t by 2 over t बच्चों. Okay, so second one is already sorted out, so t by 2 into 2. Fine. Now what about the first one? So about the first one, so I will say e raised to the power limit as t approaches 0. Now see, I can write this one as 4 into 2 raised to the power t. See, we have a standard result, and the standard result is limit as x approaches 0, a raised to the power x minus 1 upon x minus 1 is nothing but ln of a. I believe all of you must be knowing it. Okay, so I am moving towards that direction only. So I need 2 raised to power t minus 1. Okay, but I have 4 common, so I will take 4 out of it minus 1 and I will write t here. So that means I had minus 4. So I had minus 1, I need minus 4. So that means I need to add plus 3 also. So let's do it here. So now this I can write 3 into 3 raised to the power t. Okay. And then again minus 1 by t. Now check it out. Everything is balanced. How? Minus 4 plus 3 is minus 1 and rest is balanced. Okay. And this is nothing but of course limit as t approaches 0 ln 1 plus t by 2 over t by 2, which is of course 1. So that's 1, so it's half there. Okay, now let us put the value of limit. So e raised to the power, as t approaches 0, it's ln 2 4 times ln 2 minus 3 times ln 3 by 2 here. So it's e raised to the power ln 16 by 9 by 2. So I will take 2 to the, it's not 9, it's 27, just a minute, it's 27 here. Okay, so it's 27. Now I will take 2 to the inside ln. So we have e raised to the power ln of root of this, so it's 4 over 3 root 3. Now so therefore the final answer is, according to me, the answer is 4 over 3 root 3. Why so? Because again, we have a property which says a raised to the power log t to the base a is nothing but t. So e raised to the power ln of t is nothing but t here. Okay, so that was a question based on 1 raised power infinity form, bachcho.